So thank you for tuning in to this side conversation about DOM and Canvas and everything else. All right, so we go in an hour or we go until 10? Either way. I'll decide. Okay, everybody. So I'm Joshua, and today, first, before we get started, I wanted to tell a story. So, thousands of years ago, in the cradle of civilization, we have a story from the book talking about technology. They said, let's take clay and fire it and make bricks. What are we going to do with the bricks? I don't think they knew what they were going to do with the bricks. And that is honestly the story. And, that's my talk. We're done, right? That's technology. I used to be a director of innovation at Deutsche Telekom, the parent company of T-Mobile, doing augmented reality, virtual reality, robotics, Internet of Things, working on all of these different things. What's the next technology and how can we use it and how can we leverage it? And so many of these technologies are in the category of, we built it, now we need to figure out what to do with it. We have glasses with screens in it, but what can you do with the glasses with screens in it? We don't know, and we're going to figure that out. So, thousands of years ago, the same problem happened. We built the bricks. Now what? Let's build a tower to show how great we are. And I love this part. God comes down to look at their little tower and to see, we're awesome, we're great, we're so magnificent. We built this great, awesome, powerful thing, and then, let me come down and what is that you made down there? Okay, and then God confuses their language. But what's interesting is that God he says something very specific that I think is really applicable to what we want to talk about today. He says, because they are unified, they can do anything. Because they are so unified, they speak the same language, they have the same goal, and because they're working together, and because they are working together in the same goal, they can do anything. Unfortunately, the anything they wanted to accomplish is showing how great they were. There was no humility in what they wanted to do. So today, as we're talking about OpenFL, I believe that OpenFL is a practical 2D framework for game development, for interactive development, and I want to contribute together in building something great. But I think those 2 points are important to remember as we move forward. The key to being able to accomplish things is being in unity. That if we, and by that I do not mean, actually, yeah, just wait until the next Unity release comes out and whoops, not getting anything done today. But yeah, if we have common goals and we can work together towards those common goals, then the Lord of the universe said that we can do anything. But we also have to remember, why is it that we're doing that? And I think at the end of the day, the reason why we do what we do has to be bigger than to show who's boss, to show how awesome we are, to show that we're mighty and we can accomplish all these great things. Because at the end of the day, it ends up being just this. But if we affect people in a positive way and we make the world better in some way through what we do, people are eternal. And everything that we have here is going to blow away, but people last forever. And so if we are investing in people, we're investing in eternity. And I think that we have the possibility to do that. And now that might seem a little bit silly. Okay, let's talk about we're going to go to the web and we're going to, invest in eternity by doing that. But I really do think that even in small ways, if a person goes to their job and they love their work and they enjoy it and they come home and they kiss their wife and don't kick the dog, the world is a better place, right? Like in some way, we've made the world a better place. And I think that even with little baby steps like that, we can make the world a better place. So first, I want to talk a little bit about some of the partners and contributors and companies that have been using OpenFL and contributing to OpenFL. But honestly, at these companies, they're just regular people. They're just people like you and I who have a problem, they find a fix to the problem, and they shared the fix to the problem so that everyone could benefit. First one I wanted to talk about briefly is InnoGames. Now, I'm not going to go into depth on InnoGames. You can go back through the Haxe Summit talks. They've got extensive talks about their tech and what they did. But in a nutshell, InnoGames is a company who has between 200 and 300 million subscribers. And they have a giant code base. And what are we going to do with this code base? And they explored different options. They used another framework written in TypeScript. They worked through different technologies. And then they, maybe as a last resort, maybe not, came to OpenFL, but then realized, wow, actually, things are running great and things are working great. And the goal of OpenFL really from the beginning has been, let's create something that's going to be production ready. Let's create something that we can release that's going to be a real product. And in this space and what we do, there are a lot of technologies that are promising, that are exciting, but you can't ship it. You just can't build a real product with it. So InnoGames has created an automated pipeline where they can take their ActionScript code, release it through OpenFL to HTML5 while they still release to Flash using ActionScript. I think porting to Haxe is a little bit easier than trying to maintain two code bases like that. But every company has their own goals and everything else. And InnoGames has been contributing fixes and improvements and other things to OpenFL, help make it better. FlowPlay has been made big investments into the OpenFL platform, particularly in the realm of 3D. So if we rewind the clock, Zynga had I think it was 2012. The guys who made Cocos 2D, if I have my story right, and I'm sorry, Internet, if this is wrong, this will end up being old wives' tales if I'm wrong, but the story as I understand it is that the lead developers of Cocos 2D came to Zynga with the responsibility of how are we going to build something that takes what we're doing in Flash and brings that to mobile in the way that we want to do it. And they were limited at the time. They wanted something more native. And so they developed something that they called PlayScript, which was, this is going to be the new way that we do Starling games, and this is going to be the new, and it's gone. But Zynga gave us the code base and said, here, you might be able to use some things from this, and we got a new Stage 3D implementation. And that's where stable Starling support, AGAL support came from. Working with FlowPlay, FlowPlay is invested in taking that contribution from Zynga and really polishing that, and ultimately rewriting significant portions of it. But taking that core of Stage 3D support and bringing it forward to now, where not only does OpenFL support stable versions of Starling, but in the past year we've had Haxe-based releases of Starling, as well as NPM-based releases of Starling for JavaScript, TypeScript, and ActionScript users. More on that later, but the same day. I think at worst it might have been the same week, like a year ago, but as far as I know, it's basically been the same day. But that's been because of FlowPlay's effort and the way that FlowPlay is invested in supporting OpenFL. And really why this event is happening right now is because FlowPlay wants to share what they're doing and wants to help you and help other people and to share, because you can make, again, we can write the code and then we can hold on to it and say, okay, I've got my share, good luck on getting yours. But maybe in some way we can take the effort and the work that we've already done and we can all benefit. Instead of, it's not a zero-sum game, and we can have a win-win. So we can win, you can win, we can all win together. And so FlowPlay has really helped significantly in investing into OpenFL. Another name that you've probably heard before in OpenFL circles or outside of OpenFL is TiVo. I've said this before in previous talks, but I'll cover it briefly if in case you don't know. TiVo, the whole UI, the whole front-end experience is driven by an Adobe product. That Adobe product is licensed, and in essence, we see things sunsetting. not only the licensing or the restrictions that they had on it, but there were just business reasons why they were looking for an alternative. So working with OpenFL has given TiVo the opportunity to take their existing UIs, more than 1 million lines of code, and to bring that into something that's native code optimized for their set-top boxes. And they have very, very strict restrictions on what can fit on the box and the performance and the memory and other things that they need out of it. And anecdotally, I don't have the graph, but it's really fun. Anecdotally, when they released the new version of their UI, nothing changed in terms of the experience. They didn't overhaul the design. They didn't change the animations or anything else. All that changed is that it went from being written in ActionScript and running on the Flash runtime to being written in Haxe and running through with OpenFL. And the user experience and surveys went up by about 80%. 80% people were like, oh wow, I love it. My old set-top box feels like new. It's so much snappier, it's so much better, it's so much I don't know what you changed, but it's great. What changed, incidentally enough, was moving to OpenFL. And that's actually something that I really enjoy with Vegas World that FlowPlay has produced. Again, anecdotally, your mileage may vary, but anecdotally, the Vegas World code base moved to Haxe, and you can see talks about it in previous Haxe summits and everything else. It moved to Haxe, and by doing so, rather than using an AS3 to HTML5 pipeline trying to automate ActionScript to Haxe conversion, the code base becomes Haxe, and now the code base goes to Flash and goes to HTML5 simultaneously, the same code base. You A/B test it between users, and sure enough, realize, you know what? The HTML5 version is just performing better. So much better that it was a footnote in a meeting. Oh yeah. Everyone uses HTML5. Oh yeah. No, it just works so much better. We don't want to send anybody to Flash. It's just better. And what changed is that's the moment that the technology not just was using Haxe to have independence, technology independence, but it actually had moved to running on a new runtime, running with OpenFL, and in essence, though, running without a runtime. And that's really a key thing here, is that by being a framework and not a runtime, OpenFL allows the code to just become a native citizen of wherever it's going. So you go to HTML5, and it's just JavaScript. It's JavaScript, all the way down. It's all turtles. It's all JavaScript. That's what it is at the end of the day. And there is no runtime. And so the heft or the weight or the restrictions that might come from having a plugin are gone. Another partner that's been working with OpenFL is Level Up Labs. If you've been on Twitter, if you're interested in development on consoles especially, you've probably heard of Lars and Level Up Labs. Lars currently has his game released on the Nintendo Switch. Lars, don't be angry if I have this wrong, but PS4 and Xbox, and there are other developers now who are benefiting from this work. Double Kick Heroes is running on the Nintendo Switch, and the code base is, in essence, it's near official OpenFL. It's near identical to the standard OpenFL code base. The only reason why it's not out on GitHub in a visible way is because of non-disclosures. So if you want to go get a developer license for Nintendo, sign in. There's a page in there. It talks about OpenFL. You can say, hey, I want to develop for the Nintendo, and we'll get an invite, and we can give you access to the private chat and the private repos and all these things. And you can get a dev kit, and you can be a Nintendo developer, and your childhood dreams can come true, maybe, if that's your childhood dreams. But again, Lars is just one person, and he has a business, and he has employees, and he has people that he works with, but he made a decision to contribute to OpenFL and to help make it better. And I think that more and more, as these different types of contributions have come in, OpenFL today, and this was part of the side conversation if that came through in the stream, OpenFL today is one code base. If you go back to OpenFL 5 years ago, we had different code bases for different platforms, and there were different issues. But because OpenFL is one code base now, every time we have a fix for Nintendo Switch, we have a fix for HTML5, we have a fix for iOS, we have a fix for TiVo set-top boxes, which is great, which is really the magic of Haxe and why we use it internally. But we'll also get to that in a little bit. Now, another partner that we work with is Mino Games. And this slide might be mildly distracting, but I figured it was too cute to pass it up. So Mino Games has contributed heavily to improving Swift support in OpenFL. So as you may or may not know, Flash development historically is very much tied to the Flash editor. So you open the Flash editor and it's visual. Yesterday, Jiraj was talking about approaching UI as UI first, graphics first. And that's really the heart of now antiquity, in a sense, Flash development, that your art, your content in terms of UI is front and center. And then your code is a layer that runs on top of that. Now, being able to create a rich UI, sorry if this is too distracting, but creating a rich UI is much easier, in my opinion, if you can see it. Do the visual things in a visual environment. And then it's really not that hard. You know what? That scroll bar is kind of in the wrong spot. I'm going to bump, bump, bump. Oh, yeah, that looks right. I want this just a little bit bigger. I'm going to stretch it. And you can do it visually, quickly. But if you're doing it in code, should that be 21.5 or should that be 31.5? I don't know. Let me rebuild. Let me wait for it to rebuild. Let me wait for it to install on my mobile phone. Let me look at my mobile phone and it's halfway through the app. So, drive through. Nope. That's wrong. Go back and noodle with the numbers again. It's really productive. So the first layer of what they helped enable was Swift support, designed primarily for UIs. So it's a 2D layout, nothing more, nothing less, but everything is named and everything is available to code. This is stable in OpenFL today. There's been investments in Swift animation, but not heavily, and I'll talk about that a bit more later. We also got video support so that they could take the most complex animations and say, we'll just turn this into a video. We'll just play a video. Unfortunately, that requires a Bink video license, which is $3,000 per title per platform. And I have not met one developer who said, I want to pay $3,000 for that. Actually, apologies. I don't think that's the price tag. And I don't even think I'm supposed to be talking about the price tag. So it might cost $dollar to use Bink Video. Bink Video works super great, but there's a price tag to it. And that's another reason why we may want to contribute and develop something using WebM or another free open source library that has a license we can use. FFmpeg is great, but we can't use that license. Once anything is GPL or so on, try releasing a console game and answering the phone call where someone says, hey, I want to modify the source code to your game so that I can swap out that GPL component in it. Could I rebuild your game so I could? No, you can't have my source code. No. And so we're just not going there. And more. I do not have the time to mention all of the people who contributed to OpenFL in so many different ways. And the thing is that when someone has some little problem and they say, oh, I have a fix, and I don't even think it's that good of a fix, and it's probably half broken, and it's really just kind of this one little dumb thing. It adds up. Pennies add up. If you've ever tried saving money, even if you're just saving pennies, it adds up over time. So every little contribution helps, and because it's going into a community where we're working together, one person might say, hey, I feel like it's half good, and I'd like to share it. Well, half good is maybe halfway there. And someone else might have the inspiration to go, oh, I see exactly what's missing here, and I think I can polish that off. and we can get that out in the next release. Or maybe not. We put a flag around it, we disable it for the next release, and we give it a little bit more time to mature. But this is the way that things go. Just like we were talking about Zynga contributing their code base, which was in C#, and saying, hey, you might be able to do something with this. Then helping port portions of that to Haxe, taking that and running with that and integrating it, and then working with FlowPlay and evolving it more, and working with Starling and fixing the bugs, and working with Away3D and fixing more bugs. It's just the way things go. If you have no bugs, you're not a programmer. I mean, in essence, it's just part of life. Part of life is that, stuff happens. Mistakes happen, and not only just mistakes, that things are not perfect. And that's okay. If we have the humility to accept that we are not perfect, and we come to grips with that, and we realize, you know what? Let's move forward then. And we can move forward imperfectly, and that's just fine. We don't have to be perfect to be fine. Now, I want to talk for a moment about the elephant in the room. If you are a Flash developer, if you are still a Flash developer, and you are writing an action script, and you are publishing to the Flash Player plugin for the web, you may think, I have time, and things are okay. I do not think things are okay. And I would recommend kindly that you consider moving forward. Moving forward. Now, that isn't to say how great Flash is. I know. And I look on the internet, and it actually frustrates me. If I try to search for anything about how great and awesome Flash development is, you know what I find? I'm sure you know what I find. Oh, Flash is dead. Good riddance. We didn't like it anyway. We're so glad that it's gone. And it's just forgotten. But there's something really interesting about that to me. So we say EOL 2020. And that will be the year we all see perfectly, right? So EOL 2020. But this week, I was reminded of a few things that I'd forgotten. We talk about Flash, we talk about 2020, but we forget about the end of life announcement from 2012. No more Silverlight. Oh, good riddance. We didn't like Silverlight anyway, and whatever else may be. But what about the EOL from 2016, when Unity was EOL'd? The Unity web player was EOL'd in 2016. Oh, good riddance. We didn't like Unity anyway. I don't think we hear that about Unity for a few reasons. One, Unity does have an alternative, or they proposed an alternative. In 2016, I don't feel like WebAssembly was an alternative. And today, that's still, it's a growing field. It's the way that HTML5 goes. Flash came out with features. 10 years later, the browser mostly caught up on those features. It's just sort of the nature of all browser vendors versus one plugin. And that's the benefit that plugins brought us, but today browsers have come up to a point where we say it's good enough, and we'll just have to be patient for the rest of it. And I think, honestly, I think that that's okay. But we didn't hear about it not only because Unity did have an alternative for developers, so developers didn't shed as many tears, perhaps. But I think the other one is that the Unity web player was never, ever, ever as popular as the Flash player. The Unity web player was never, ever, ever on as many websites or as ubiquitous. And why is that? And people would say, oh, well, it's because of advertising. Flash was everywhere because of advertising. Advertising is everywhere with or without Flash. It's not Flash's fault that's why, I mean, Google exists. 98%, last time, I could be wrong about the statistic. You know, I should probably check my statistics before I come up here and start throwing around numbers. But last time I heard, I believe it was high 90s, 95 to 98% of Google's revenue comes from ads. So you say, well, I don't like those ads and I want to get, well, that's why you get an Android phone and you don't have to pay for the platform on it. That's why you get Gmail for free. That's why you get all these things for free, because nothing in life is free. So it's not free. Instead of spending money on it, you spend your time. They take your time and your data. And they take your data and your time, and they hope you'll click on an ad and put money in their pocket and feed their kids and help them take more of your data and more of your time. But that's just sort of the nature of the tech industry today. So it's not the advertising. Flash was ubiquitous because Flash enabled us to do something that we could not do on the web before. The web was a place, at best, with frames. We could have content, and you could have a dragger on it to resize something. You could have a MIDI, and you could play the most, well, actually, I had a pretty sweet Yamaha plugin. And that made it sound like a real synthesizer. So I'd like have my collection of MIDIs. I'm going to listen to my Depeche Mode MIDIs or something else. And Comic Sans was cool, okay? So I had my website. It was Comic Sans. It had the little digger construction guy. It had frames. It had MIDIs. It actually had a whole page dedicated to animated GIFs. So you have your icons and you have your animated icons, so that you can say at the bottom, not only that 253 people have visited my site since it was created, you could also say that it was made for Netscape Navigator. The web was a very different place, and when Flash came in, it said, here's animation that's smooth and fluid. Not even just, there was no animation other than the little digger guy. There really wasn't animation. So we had animation, and it was smooth, and it was fluid, and we had sound, and we had video, and we had all the things that we think of today as the web. Flash really was what helped bring that to us. It was the carrier of that. And today, we say, oh, good riddance, we don't like Flash anyway. But it's the end of an era where the big plugins, Real Player, I don't know when Real Player was EOL'd. Was it EOL'd? I have no idea. We don't know. We don't question this, because Real Player as a plugin disappeared from our minds. Silverlight disappeared from our minds. Unity Web Player disappeared, and we don't talk about it. And so 2020, in a year and a half, give or take, in 2020, end of 2020, Flash Player is going away. But that's just the nature of things. Plugins are going away. So why would you want to use OpenFL? You're using Flash, or you're not using Flash. You're a developer. I think one of the key things that OpenFL gives is technology independence. Now, this is something that may be underrated. I think that as an ex-Flash developer, I could see the virtue in it, because my eggs were in one basket. And then that basket caught on fire. And you have to decide what you're going to do about that. So someone says no vendor lock-in. If you've never been locked in, you think, well, I'm not too worried about that. And if you have been locked in, you realize, gosh, that's the way that it goes with insurance policies. Someone thinks, oh, I don't need insurance. And then their house gets robbed, and then think, well, maybe I should have had insurance. Technology independence. So OpenFL, as a framework, is designed to give you technology independence. So today, you can target the web. We support straight vanilla JavaScript, and you can integrate with straight vanilla JavaScript. Not only that, OpenFL does not need to be written in Haxe. You can choose any JavaScript-based language. Something that compiles to JavaScript, it will work with OpenFL. You can write in ES5. JavaScript the way it was. You can write in ES6. JavaScript the way it is now. You can write in TypeScript, JavaScript plus some types on top of it. You can write even in ActionScript. Adobe open sourced Adobe Flex, and it eventually turned into Apache Royale, which is now back on NPM and is available to compile ActionScript code to JavaScript. And that works with OpenFL. I don't think that's production ready, in my personal opinion, but you can try it out. You can contribute to it and make it better if you want to. But the point is that OpenFL has put itself in a position with the goal of not just allowing you to create production-ready content, but to put you in a position where you are now independent of these shifts in technology. So if WebAssembly matures and WebAssembly is better than plain vanilla JavaScript, we've had support for WebAssembly for years. It's there. You can take an OpenFL project and compile it. You might have to fix some bugs in the scripting compiler or something else, but it's there and it can work. And I used it for 2 years, and HTML5 plain JavaScript beat it hands down every single time. It runs fast. You get 300 kilobytes and you have your entire project instead of 10 megabytes of maybe it'll run, maybe it won't. But these are all things, again, these are all things that can change. Flash was the way that we did sound and video. Today it isn't. Today, plain JavaScript might be the best way to do it. Tomorrow, maybe WebAssembly is just better. But again, this also depends on who you are. If you're TiVo and you want to release something on the don't use the canvas smart TV, then maybe you just want a DOM target. You just want something to target the HTML5 DOM, and you don't care at all about these things. But if you're a game developer, maybe a 10 megabyte download really isn't that bad. And you know that your users expect it's going to take a little while to download because you have a lot of great content for them. So OpenFL gives you these options. You can be native or not native. You can run in a runtime or not run in a runtime. It's your choice. So briefly, one of the questions that I've gotten before, I'll say that second. The first thing is, a lot of this technology independence really comes from the fact that OpenFL is written in Haxe. Now, whether you as a frontline developer use Haxe yourself, we use Haxe. We use Haxe. And because we use Haxe, we have this level of technology independence. Our code can now become reliably, not just a fairy tale, reliably Java. It can become C++. It can become bytecode for the Nico runtime or the Hashlink runtime. It can become JavaScript. They're adding a new JVM binary target. It could even go to PHP. I don't know what you would do with PHP with OpenFL, but you could. If you want to have an OpenFL matrix in PHP, you can. And that's the interesting thing about technology independence. It's not that we have to do everything that we could, because we know we can, but that it becomes a business decision. It's not a tech decision anymore. It's not the engineers saying, by golly, we can't do it. Or we can do it, but we'd have to rewrite everything. It's the business decision of, do we want this new platform, or do we release in this way? And we have freedom. But the second thing, though, that I have been asked a few times of why is it that we use Haxe? And I think that it's important to note, just briefly. We could take OpenFL, and honestly, as a community, I'm open in this discussion. So as contributors to a platform like OpenFL, we could rewrite it. It wouldn't be hard. We could build it to JavaScript and just keep that and move forward. But what would we lose? Why would we want to have it all written in JavaScript? If it was all written in JavaScript, yeah, maybe it would make it easier for some people to contribute. Maybe. They don't have a compiler. But the honest truth is, with the npm release of OpenFL, it's just an npm run command anyway. It's kind of the same thing. You're launching your web server, or you're building your Haxe code for a second, and then you're launching your web server. It's not really that different. But what we would lose, though, is the typing, especially. And the typing that we have prevents so many bugs. It prevents so many dumb problems. So we can move on and we can solve the interesting problems instead of solving the problems where, oops, I put the engine in upside down. Sorry. That we don't have to deal with those types of issues, that we can get an immediate compiler error and we can fix it and we can move on. But why don't we just rewrite it in TypeScript? If we want to have types, why not rewrite it in TypeScript? But for the same reason, the difference between JavaScript, TypeScript, and Haxe is that instead of adding a little bit of sugar on the top of JavaScript, which itself is very, very dynamic. And that's okay if you know what you're doing, but if by accident or in a large team or something else, you do something wrong, you can really not only get yourself into a pickle, but also you can unintentionally hurt your performance in significant ways. I personally had one instance where I had one line. Haxe allows you to do untyped code. where you say there's no types, I know what I'm doing, I'm going to do this one line of untyped code. That one line of untyped code was costing 20 seconds worth of CPU time on a 3D project. What? And it was just an object assignment. But that object assignment caused the JavaScript optimizer to say, oh, I can't optimize this anymore, and to throw the entire project into a dynamic mode that killed the performance. And it was one little untyped line of code. We've taken other code bases and ported it from JavaScript to Haxe and seen performance improvements in the ballpark of about 15% just by changing it to Haxe, because Haxe is a compiler, it dots the I's, it crosses the T's, and V8 and other engines just are happy with it. But why don't we just rewrite it in C# or another language? I think technology independence is a really important one. We could rewrite in C# and we could be happy until we want to go on a new platform. And oh no, there's no support for Nintendo Switch. What do we do? And then we try and hire someone really, really smart to try and figure out the really, really hard problems that come up when your runtime doesn't run on the platform you want. And we could solve all of those problems, then, oh no, what about the web? Or oh no, what about, and there potentially is always an oh no, what if? So moving forward, I want to touch briefly on some of the things that we've been doing the last year and some of our goals moving forward. But I want to say this again, that OpenFL is an open platform. We want to work together on making it better. And what we're working on moving forward and what the priorities are, not only is an open discussion, but it's also up to you, in a sense. We'll talk about that. But this year, some of the points that we've been working on, first, and this might not seem like a big deal, but if you're TiVo especially, this is a big deal for you, per file stability. So OpenFL, by nature of all the changes that we've been trying to do and all the architectural decisions, we're gonna bring in Stage 3D, and we didn't have that before. We're gonna try and improve Stage 3D, but oh no, there are state issues between our renderer and Stage 3D rendering. So we're gonna renovate how we're doing our rendering so that the two are in sync. And this has caused some levels of instability. Where are the files located internally to OpenFL? The external APIs remained largely unchanged, but the internal API as a contributor, sometimes things move around, and where did it go, and what happened to it? Or people debate over their favorite coding style. Should it be brace on a line? Should it not be? Should it be cuddly? Should it not be cuddly? And so one of the things that we've worked on this year is improving per file stability. So that not only means reducing the number of instances that things are moving around. And in essence, I think OpenFL has developed to a point where really what we need is polish on the top. We don't need to rewrite the thing. We just need some extra performance, some extra bug fixes on top of it, so that it does what it promises to do a bit better than it did yesterday. We also adopted the Haxe formatter. So all of the code inside of OpenFL and inside of Line is automatically being formatted to a code standard that's not my standard. It might not be your standard, but that's okay. It's a standard, and it's a standard that we don't have to fight about it. We don't have to think about it. It happens automatically when you save a file if you're using Visual Studio Code, and we can just move on. And so as we move forward and we work with larger contributors especially, your diffs and other things like that can remain largely unchanged. If there's a diff, something happened there. Not because the white space changed, oops, it was spaces instead of tabs, and the whole page is tabs, and these different types of things that come up. So this might not seem like that big of a feature, and it's not really a feature, but as we're moving forward and we want to work together, it's just a community standard of saying this is going to be our code, and we'll move forward, we'll all work on it. Another goal this last year with OpenFL has been to improve our testing. OpenFL can do so many things, and because it can do so many things, sometimes it's easy to fall into the trap of wanting to do many things, maybe more things than we can handle. But unit testing is a really significant part of ensuring that as we move forward and as we improve a feature, that we have confidence. And especially when it comes to new contributors, new pull requests, if we have unit tests to cover that, why do we even need to think twice about it? If you say that this fixes your bug, and we have enough tests to know that it doesn't make things slower and that it works the same as it did before, then I can almost take your word for it without even looking at the code at all. Now, this is a thorny issue, and we're still working on solving this. But just briefly, I want to explain, we've been investing into the munit library, which has been a long time library in the Haxe community. We've helped merge in fixes the TiVo made that they needed for running asynchronous tests or running data providers and other features that were useful for them, and formatting it in a way that it does not break the existing API. We're waiting to get those improvements merged upstream. But in the meantime, we're leveraging munit, and we currently have 3 different types of tests for OpenFL. And I'm hoping that this covers it, and I'm hoping that we can write more tests together to confirm automatically that OpenFL is stable and that we're not having any regressions from release to release. We have unit testing that's run on only one target, and that's only logical tests. It runs fast, it runs quickly. It doesn't test every platform, but we don't have to. Because if we're testing the 2 and 2 indeed makes 4, the difference between JavaScript and C++ is not going to make a difference. Haxe abstracts that part away where we really don't need to think about that. But on top of that, we have integration tests where we are running in a real environment with a real window on a real platform, and where we do run it on each Haxe technology that we support, just in case. As well as additional tests to use the file system or use networking or other things like that that we can do in a headless way, in an invisible way, automated every time that we contribute code, but it's just a little bit more complex. The third suite of tests that we're starting to work on developing are tests where we have to QA it by hand. So we can open it up and have a mini framework to be able to tab through test after test after test that we do visually have to confirm or listen to make sure that it works the way that it's supposed to work. But I'm hoping that this process enables us to cast a wide enough net to cover what are all the things that we need to test. Because a lot of times testing gets stuck in the, I don't know how to test this. How do I make sure that the sound loops properly in an invisible way on a server? I could ask the APIs, did it play? Did it loop? But how do I know that it actually worked? And so by casting a wider net, broader net, and having these 3 different buckets for our tests, I'm hoping that it gives us an ability to say, today I don't know of a way to do it except to do it myself. And to put it in the functional testing, to have a test for it. And honestly, this is a mini test that we can iterate over. So if there's an issue with the sound playback, we can run the functional test only on the sound, and we can loop over that over and over until we fix it. Now we still have a suite, though, that we can go over before we do a release. If someone has a clever idea and said, you know what, I'm going to talk to the sound driver on Linux especially, and we're going to figure this out, and we're going to know that it indeed is playing our sound, and we can take that and we can move that down into the integration testing. Now it's a Linux-only test. It requires a system. It's not logic, so it has to live in the integration testing. But we have a place to put it, and we have ways to get it less and less manual so that it can become more and more of an automatic rubber stamp. We also are working on a new model for contribution and for bringing in contributors to the project. So in the past, we had a model that primarily was based on pull requests. So you write a pull request, you make a pull request, hopefully it's good, or that's what we tell ourselves, hopefully it's good, and then maybe it gets pulled and maybe not. And I fear that this model has broken down a little bit, and this really kind of goes back to the testing, but unfortunately, some fixes are small enough and clear enough that it's obvious this breaks nothing, this fixes a small bug, and we can safely merge it in, no testing required. Other things are a larger thing, but testing it is isolated, and it's not difficult to say, okay, we're going to test this, we're going to get this working, and we're going to make sure that this becomes stable. So we'll pull it in, and if there's any issues, we'll continue to work that out. But sometimes things fall into this in-between limbo. It's a good feature, it's a good fix, but we don't really have a way to test it. Or is this going to break something is this going to have unintended consequences? And sometimes that indecision ends up causing really important contributions to take more time than they should. It causes OpenFL to be forked instead of us working together on the same code base. So our new model moving forward for contributors, and again, we're still open to feedback on the best way to do this, but right now, the model that we have, if you start making contributions, you're talking on the forums, or you're talking in chat, we're talking together about a fix, and you start making contributions, or even without, we're not communicating well, but still you're starting to make contributions that we're merging in, then we'll elevate you to having commit rights to a dev branch of the library. But then we also have what we want to become a stable branch of the library that automatically merges in when all of our tests pass. So rather than letting everything live in separate places and trying to pull them in, the problem is sometimes a feature is only half done. And instead of feeling like a feature needs to be fully complete and fully tested before it comes in, I'd rather things come in, even if it's only half done, so we can all work together on it. In line with that, OpenFL now has a draft flag, or draft define, where we have our standard source files, but we also have a draft directory for new classes that are proposed to be added to the OpenFL library. Within the existing classes, a new feature or new change could be added behind a draft define. So it's in the code base, it's not a standard part of what a user is going to use, but if you define draft or OpenFL draft, those new APIs and those new changes are going to be available, and we can give those changes time to mature until we're ready to promote them to being a part of the official library. And again, by separating our branches, hoping that we can create isolation so that we can work together on an unstable branch, and then we can try and move that up to a stable branch as those things mature, and then eventually to a release. The last thing that I wanted to mention, so this is a Swift from Pixel Raccoons that's working on a pirate fantasy, but a lot of other developers, I mentioned Mino Games, that leverages the Swift support a lot. As we look forward to the end of life for the Flash Player plugin, I don't know what the future of the Flash runtime is, but I do know that in OpenFL we're developing an alternative runtime. So today, we can leverage the Flash runtime and use OpenFL for other platforms, other places outside of the Flash runtime. So we have our foot in both. Swift support, I think, is going to be a key feature moving forward, because more and more, I think, any remaining content that's in Flash that wants to come over is going to expect not only to be able to use that environment for creating a UI, but also to have heavy use of animation. And this has not been a focus of OpenFL so far. But I think that moving forward in this year, in addition to having more contributors and working together and finding ways that we can get our code in the same place and refine it to make OpenFL even more stable and even faster than it has been, I think that Swift support is going to be important, because not only is it a feature the Flash developers are using, but I also think that it's a feature that if you haven't used it before, you almost don't know what you're missing. Because again, if you're coding a UI in code, 10 pixels here, 20 pixels here, oop, doesn't look right, 20 pixels here, 20, it's a very, very, very different experience than if you use a Swift. Even if you see this big red spot, that's just a placeholder. In code, you can say, where is it, how big is it, and then put your content in the same layer, same place, same size, so you can have a visual environment. Even if you're just creating the boundaries of what you're going to do in code later, it still gives you some visual feedback to work through that. So moving forward, I think that's going to be important. So OpenFL for InnoGames, for FlowPlay, for TiVo, for Mino Games, and for Level Up Labs, and for so many other contributors and users of OpenFL has been a practical 2D platform for developing their games, for developing their interactive UIs and their interactive content. I believe that OpenFL year after year has been getting better, and I am so thankful for everyone who has contributed to OpenFL. But I believe that together, if we have both unity and working together, I believe that we can do anything. But if we remember humility, remembering why we do it, that it's not about showing how great we are, but maybe in some way leaving the world a little bit better, even if all the code we write is forgotten. And with that, thank you. Appreciate it. I don't know. That's time. So, well, that's 10. We started about 15 minutes late. Okay, go for it. Yeah, so anyone who didn't hear, the question is Swift support. So is Adobe going to kill Swift support along with Flash Player when they don't need it as a format? I think a really easy answer to that is that Adobe Air still relies on it. So as long as Adobe Air is there, they're still going to have the format. But I think that there's a better answer to that. If you go to Adobe's website now, I don't even know how you find Adobe Air, really. It doesn't fit into the Creative Cloud. It's not part of the business model of where the company's going. And that's okay. That's Adobe. We understand Adobe, Photoshop, everything else. I think, though, that Adobe Animate does appear to have a future. It appears that Adobe, as a part of the Creative Cloud suite, the former Adobe Flash Professional, now Adobe Animate, is still going strong. It's continuing to focus itself more and more on animation, like for TV, or for creating web content, which doesn't use a Swift. However, there's two things about that. As long as Adobe Animate does support Swift, we have the ability to support that and run that through our converter and everything else. The second part, though, is that when I say Swift support, one is the package format, and the second is the runtime support. So if we change the file container, there's all the runtime support of having animations and having layers and being able to do that in an effective way for performance and memory. All of those improvements apply even if we change the container format. And the last note about that regarding Adobe Animate actually has a plugin system, and we have a custom plugin. And in that plugin system, we can see the entire DOM of everything that's inside of Adobe Animate. And it's C code, and we can write whatever we want to export this content. Today, we export it as a Swift so that we can do all the conversion in Haxe. But tomorrow, if Swift disappeared and we had to, or we wanted to as contributors, we could go in and we could write something better. And maybe we could have Haxe code on the timeline or something else. There are a lot of possibilities that we haven't really tapped into in what we could do with Adobe Animate specifically. But I also think that universally, we really want to have animation support and UI support, whether it comes from Animate or comes from any other. If we find another 2D layout tool that's great, we can just hook that up into the same pipeline internally. Sorry if that's too long of an answer. I have spoken with Adobe before, not recently. I don't know. I think it depends. So I guess I would say, so Adobe Animate. I told you before that Adobe Animate has a plugin system. We did work directly with Adobe on that. So before they announced that they had the plugin system, they were working with us. They were working with other partners to say, we'd like you to be able to have support for, and that exists today. You can open up Animate, and if you install the plugin, you can say, I want a new, and instead of saying an AS3 project, you say, I want a new OpenFL FLA. That gives us the ability to disable features that we don't support, but it also, like I said, gives us the ability to kind of customize what's going to happen when we publish. But right now, we still export it to Swift, and we just use it from there, but I think there's still a lot more we could do. Yeah. So the question is about testing. I had mentioned the unit testing and the idea that it's a logic test and that we can safely assume that Haxe has abstracted that and we don't have to run it on multiple platforms. And how do we make releases with confidence that things are working because of if more than one technology or platform is being supported, some of these things can't, it doesn't feel like these things can be tested unless it's run on the platform. And on that note, I guess I would say, so when I say a logical test, I think of something like, like yesterday, Raj was making a calculator. So the logic of that calculator, in theory, is not platform specific. So that logic is something that if you have a test that runs it and it says this logic's good, your calculator is mathematically correct, then you can take that with probably a high level of confidence that even though there is the possibility of having an integer overflow or something else on a specific platform, the chances are I can take these confidence and move it forward. But that's actually why in our integration tests, when we do run for each technology, we rope back in the same unit tests just as an extra check, just in case, the unit test passed fine, but now that we're running specifically in CPP or specifically in JavaScript, let's just go ahead and do that again, just to make sure there's nothing funny, no funny business in there. But I guess the other thing about it, you mentioned the difficulty of moving towards the release and then realizing that there's an issue with sound or something else. And I think that's really part of why I want to try and contribute more to testing OpenFL as a code base, because as we test and we increase the confidence of OpenFL, it helps increase the confidence of which features are guaranteed to work above. And so when we realize that, for example, realizing that Howler.js that we use for audio on the web, realizing that browsers have just broken one of its features, if we're catching that in OpenFL and realizing, by golly, there's an issue here, and we can pull an upstream version of Howler.js that already has the fix, or we can work on making the fix ourselves. That fix then benefits everybody else who can then say, with increased confidence that as OpenFL is being tested and being rubber stamped as being confirmed and approved, that it's working. And it is difficult, though, when it gets into specific devices and other things like that, how we're going to test all of those things. And that's part of the problem that we want to continue working on trying to solve. And worst case scenario, again, with the functional tests, it might just be running a device and tabbing through 30 or 40 tests manually on the device, but we can confirm that we saw it working and that it worked before we do a release. But I think that there are better ways to do it. There are ways to do headless browsers. There are a lot of ways to do desktop testing without actually sitting at the desktop. Mobile, I think, is the trickier one, but even then, I think that there would be ways to run in simulators or emulators in a headless way. So I think it's somewhat of an unsolved topic, but it's also something that I think we've been taking strides moving forward. I'm pretty proud of what we've been able to do so far. Okay, thank you.